Welcome to VSS Monitorings podcast series, the podcast series dedicated to helping you, the network professional, increase visibility to all of your users and lowering your costs while doing so.
Hello and welcome to VSS Monitorings monthly podcast. My name is Mark Laducci and I'm an account support engineer here at VSS. I'm joined by Brent Green from our engineering team. This month, we're discussing vAssure, VSS Monitoring's proprietary technology for tapping gigabit copper networks.
Today we're going to discuss basics of tapping gigabit copper Ethernet and traditional methods to minimize failover times, as well as vAssure VSS's hyperfast failover for gigabit networks. So in traditional 10100 Ethernet copper networks, our taps behave as straight-through cables at all times, meaning end device A and B connect directly to each other. And we can do this because we're only using two pairs at any time, and we know that one pair is always RX and one pair is always TX on that line. So simply connecting the two end devices together and physically tapping into those links, we can copy off data and send that out to monitor ports. Now on gigabit Ethernet, things change because we use 4 pairs of wires, and those all transmit and receive bidirectionally at the same time. Since they're both transmitting and receiving at the same time, if you were to try to link or look directly at the link physically on the wire with a scope, for example, all you would see is noise, and the only way for one end device to know what the other end device is communicating is by subtracting its own transmit signal. In essence, this means that the 10100 model for tapping a network is not viable in gigabit copper Ethernet, and this is not something strictly related to tapping the network, but as well it is due to the IEEE standard for gigabit copper Ethernet, and not something that can be worked around. So when you power off a gigabit copper tap, or while the power is off, the two end devices are linked directly to each other through a direct physical connection. When you power on the tap, that physical connection must be broken, and the active components inside the tap then connect to the two end devices. Now when the power is off, since they're connected directly to each other, the end devices must know how to negotiate between each other and get the right speed and duplex. While when the power is on, they need to be able to negotiate with the tap in order to link at the proper speed and duplex. So once the power is on and the unit's operational, if there is a power failure, that physical connection between end devices A and B, for example, is restored, and those devices communicate to each other directly. Now in traditional copper gigabit Ethernet, this requires that auto-negotiation restarts every time that this physical transfer takes place, despite the fact that the physical transfer is only about 5 milliseconds in time. The auto-negotiation process restarts, and that also can affect, for example, the customer's network. If they have spanning tree protocol enabled, that might cause a significant delay of up to a minute long. So speaking of traditional methods of reestablishing link on tapped networks, one of the earliest methods and still used today on 10100 networks is the use of forced settings. Because if you force the link up at 100 full duplex, for example, it doesn't have to auto-negotiate at all, and the link simply is restored when the connection returns. However, with gigabit copper, force settings are generally not suggested and can cause other issues on the line. What you can do is auto-negotiation with limited advertising. For example, only advertising speeds that you actually want the network to link at, and this can reduce the time somewhat, but not significantly. In either case, auto-negotiation on gigabit networks can take up to 5 seconds to link up, normal values being somewhere in the range of 2 to 5 seconds. So obviously this can cause a link failure that's undesirable. Now vAssure is VSS's proprietary hyperfast failover for gigabit capable taps. And what it does is it prevents the link failure even with auto negotiation enabled. So what we're able to do is limit the amount of time that the tap takes to link up on the line to 30 to 60 milliseconds total. Now anything above 200 milliseconds on a gigabit link of link downtime will cause the link to drop and auto-neg to restart. So by limiting it down to 30 to 60 milliseconds, we prevent the link from actually dropping, and only a brief 30 to 60 millisecond section of time is there noise on the line, and that would be the only time that any data is dropped. And again, since spanning tree would be normally affected by a link actually dropping, without this drop in the link, spanning tree basically can be configured as the user requires, and that would not affect the link when it's tapped. So this also can prevent a link drop time of up to 60 seconds in the case of spanning tree. Here we have a test example of a simulation network on how to test vAssure and demonstrating how it works. We have a simple 1x1 tap. On one side, network port A is connected to a 1 gig switch and to a PC. Network port B is connected to another PC. And by doing basically a ping flood between one PC and the other, you can demonstrate the amount of packet loss with and without vAssure. And in the case of power on without vAssure, you can see that there's a significant loss of 1,600 packets. Now, in the method that we used ping in this example, each packet is about a millisecond of time separation between the next packet. So you actually kind of get a sense of time of how much time that link was down. And without vAssure, you can see it was almost 2 seconds, or it indicates 1,600 packets, about 1.6 seconds worth of downtime. Whereas with vAssure at power on, you can see the losses are similar to a normal case of power off as well, where you only lose about 30 packets. So this directly shows you the example of the difference between with and without vAssure. In a traditional traffic capture architecture scenario, the VSS taps are located in line on the networks and are the critical path to the monitoring system of that network. Therefore, you can see that vAssure is extremely important. It makes sure that there is no packet loss or very low packet loss on your network, even in the case of a power failure or a restart of the tap. So the bottom line with vAssure for gigabit copper networks is that it ensures no link failure due to the tap.
Once again, thank you for joining us on our monthly podcast. For more information on our vAssure technology, please visit us on our website, www.vssmonitoring.com, or call us at +1 650 697 8770. Ask for Mark and you can talk to me. Once again, thank you, and we'll see you next month.